Great, thanks. Okay, before we start, I got a very important question for you. Is there anyone here in this room who doesn't speak Polish? Okay, great, so we'll stick with English. That's awesome. Thanks a lot. I actually prefer this way. Okay, great. Thanks. So I want to be exactly sure you are here because you want to be here and not because you are here because of accidents. So first of all, I will say what we are not going to talk about. We will not talk about any fancy new framework, any features related to the Java directly, or even not about TDD, not even about test-driven development. Instead, we will talk about something called software design and why I love unit testing and hate them at the same time. So yeah, that's what we are going to talk about. And there will be no fancy memes and no funny cats and not such things. So if you want to still be here, that's great. OK. So I should start, what do I mean by test limits? Because that's something which is probably not found in any other places in the internet. Yeah. So test limit, in my opinion, is a moment in software development when software developers, when programmers say that unit testing is a waste of time and they gain nothing out of it. So it's just wasting a lot of time and doing exactly nothing. So that's a moment I call test limit. When we say, OK, we won't write unit tests anymore. It makes no sense for us. So why we have limits in testing? There are two main reasons. First reason is that our design is bad, and thus it's untestable. And the second reason is that we are forcing unit tests. We are forcing unit tests by policy and not by needs. So for example, when we have integration software like glue code, and we would need to test this in the integration way, we enforce unit tests in a lot of mocks only because. And that's the moment when probably developers will say, OK, that's useless. That works only in toy project and not in the real world. OK, so some assumptions in this presentation. I assume that we write unit tests to verify if our code is correct, just for the needs of this presentation. It's not always true. For instance, in test-driven development, we actually write tests before to guide the design, to create the design. So our design is a result of writing tests, of writing business specifications. But for the needs of this presentation, we are not going to talk about TDD. We are going to talk about writing unit tests for the existing software. And what can go wrong about this? So the first case, the first reason why, yeah, sorry? Yes, that's great. As I said, that's also part of the design because we have a business rules, we have a business requirements, and we create unit tests specifically when using BDD, for example, and when joined with VDD. I mean, TDD plus BDD plus DDD is a sweet spot for me. But anyway, there are cases which it works great, but there are also cases when it's just a waste of time depending on the experience of the team. So yeah, that's the first case. I agree, but it's, in my opinion, related to the way we guide our software. We guide our software by specification written in tests. That's how I look at it. So yeah, the first reason is when design affects testability. And I would like to first talk a while about design. What's design in your opinion? Can you share a word with me? Yeah, make it more interactive, please. Nope? Yeah, OK, so maybe I'll tell something and then you will join me. Design is the way we create software. Design is a set of strict rules. It's a discipline we create software. And there are two main ways we can actually achieve design. We can have design which is a result of writing tests, like in TDD. And the second case is that it can be created before, so it can be given for us. And we just need to write tests only to verify if everything is OK. And mainly, we will talk about the second case here. OK, so let's start with something juicy. Let's start with an example. We will start with 3 examples of code which has bad design and thus is hard to test. The first case is an example of a God class anti-pattern, something I call God controller, which we can sometimes find in our projects. But I'll switch to the real code here. It's probably better. OK. Yeah, so let's take a look for a moment about the method place order in the controller. Can you tell me what's wrong about it? OK. So maybe the first problem here is that we're actually having a logic inside the controller. Controller should be a thin layer, only delegating and taking care about such things as serialization, routing, etc. So the first problem here is that we are having some business lines of code, some business code here, which is calculating the total cost of the order. And then we are also having a very weak domain model where we just have setters for this. So we need to set the total cost and then set the flag to be known that this order is placed actually. Then we are having interaction with third-party services like order repository. And we are having also interaction with like something called, for example, statistics service. So this code is quite hard to test because it violates single responsibility principle in many ways. Let's check it for a while. Let's try actually to see some working tests in this example. But instead of just showing it, let's try to write it after a short description here. So in this case, I'm using JUnit5. So I'm having descriptions inside the display name. And it says, should calculate total cost and then set paid status. So you see, that's the first case. That's the first case which actually is concerned only about the business logic. So yeah, and here you see that if we would like to test if, for example, calculation is OK, we would need to create an order as a serialized form in JSON. For example, in JSON, it can be anything other than JSON. Doesn't really matter. The thing is, to test business logic, we need to think about the presentation layer. We need to think about JSON. We need to create the expected order according to the JSON. And then we can use mock, for example, to verify if order repository is saved using the expected order. That's quite problematic, as you will see, because we'll try to write it step by step and see what happens. Should calculate total cost. Just make it a bit shorter here. OK. And in this example, let's call it test live, just like this, because the description is important, not test name, as in JUnit4. And in this example, the first case would be to make a perform, right? We would need to perform, make a post according to the rule we have, according to the routing here, listening on the bad orders /bad/orders. So we need to give the name of this. Then we need to give the content, which is order as JSON, which is a string here. Whoop, now this. Local variable string. OK, and yeah, that's the part which is quite problematic because our order is actually something between the business model and something between the DTO. So it still requires a lot of manual work if we want to actually create the JSON. And using such things as object mapper is not always the best option because we are not sure what is produced. So if we wanted to duplicate this, we would need to create a name lines, just like this. OK. Then create the object for the order line, which has just one property called price, just like this. And then somehow give a string with the money value. So for example, something like this, we can say that's OK. I forget about the backslashes here to escape the sign. Yeah, something probably like that. That doesn't look very pretty. But that's the case we would need to be forced to create to test the business logic, actually. Okay, and this is the content and also the content type, because we want only to serve as application JSON UTF-8. So that's the thing here. And then what? What we would actually want to specify in our requirements here. In such situation, we would want to have status 200. That's acceptable because that means simply OK. So I'll move it here and expect status is OK. I'll also give formatting here. I'll disable the formatting so it looks a bit better. And expected status is OK. And except of this, we see that the code needs to call some other services. As you can see, it's not created before we have the code, and we need somehow to conform to the inline specification. So we are looking at the implementation, in fact, here to know what's happening. So inside the order, we would like to call the order repository with save method, having the expected order, right? So in this example, we will call verify on repository. Repository, what's the repository? Oh, it's mogbin, right? So just one time, and call the save method using the expected order here, just like that. OK. And we have, you see the class is called bad order because that's a sign of bad design. And we need to somehow know what's expected from this JSON. We have order with just one line. We make it a bit simpler because it would be harder to write it manually. So in this case, we will set lines. We will set lines, which is equal to, actually, there is only one value, so values. So collections, instead collections singleton order line. Yeah, and order line, we give it the value money of currency unit. Yeah, a currency unit 20, just probably like this. And if we want to test whether the logic is OK or not, we are forced also to verify the calculation cost, right? So set total cost, that's the sum, it's just one element, so I'll just write money of currency unit USD 20, just like that. And then we can verify if everything is OK. Let's run the test. That's our first specification taken from the outside world. Let's take a look. What's wrong with this? What's wrong with this? There is 400. There is a 400. We have here cannot construct instance of money. No string argument constructor factor method to deserialize from the string value USD 20, right? Because that's not easily deserializable. We need to write a custom deserializer for this. So you see, we just wanted to test business logic, but we need to think about the other layer. We need to think about the presentation layer when writing just the business logic test, which is not very good because there are two vectors of things we need to think about at the same time. So our attention is severely limited. So we need to somehow write the serializer. I have already deserialized it, so we don't need to write it. I'll just enable it again. It's a money deserializer. It's a JSON component from Spring Framework. So we will run this, and it should be injected and should be ready to deserialize the money. Let's take what's wrong with this again. We are probably having not the same object here. Yes, arguments are different. We wanted to have order is placed false with lines USD, but there is order is placed true. Yeah, because we are not guided by tests and we forgot about one more requirement. Set placed to true because we want to be it flagged as true. To make it flagged as true. Okay, let's check it again. What's happening? What's happening here? Write your test. Yeah, so the test passed, but doesn't really say much to us. Take a look we had to think about the presentation layer when writing just the business code. And that's just one case. To verify if business logic is OK, we would need to write a lot more of such tests. For example, when total cost is empty, when we would like also to verify the verification with other services. And for example, we will need also to handle when there are different currencies used in order lines. So there are a lot of edge cases here which need to be tested. And if they need to be tested here, we need to write new JSONs just to verify if everything is OK. So that's a bit insane. And now go back here and think for a while what would happen if our logic is much bigger here. If our logic is much bigger, we actually are forced to write a lot of edge cases when actually writing just a simple controller, which should be a thin layer over some kind of facade, just taking care about the routine and such things, not about and the business logic. So that's probably the moment when our testing is severely limited because we need to write a lot of mocks, a lot of JSONs, and that's a thing that I don't know a developer which would like to test business logic through JSONs, right? So yeah, that's the problem here. And in the good case, if you wanted to see the good case of order controller, all we would have is something just like this. I mean, there is no logic in controllers. Controller take care of such things as routine. So in case of Spring, it's request mapping, such things as handling the right verbs, like post mapping, and testing whether the object is serialized or deserialized properly. Such things, not any other things with logic. And if our design was like this, we actually could write a very, very simple test. For the good controller, that would be all we would need to test, right? If given some JSON with some properties, we just verify if it's deserialized correctly, and then if the order facade is called with the deserialized object. So we just care about deserialization, we just care about having the right routings, we just care about handling properly HTTP verbs, such things. Nothing more, in fact. And that would be enough for a simple controller, because there is no logic here. We just can integration test it. That's basically all about it. OK, so let's take a look at the other case. The other case would be something called the strategy. If you only know strategy, it doesn't look very good here, so I'll just switch the code again. So let's switch to the code. Bad order service. Yeah. Take a look at this. There is a place order again. It applies a discount for the order and then saves the order inside the repository. OK, so what's really wrong about this? The bad thing is that we actually have a lot of inline logic. You see, for instance, it's not obvious that this line applies a special Christmas discount when it's December. We need to read the code. We need to check all lines. So that's a problem about this. We need to think what it does. That's the first thing. The second thing is that we actually need to handle a lot of other possible strategies. So what happens is, for instance, total cost is greater than or less than such things, right? And now imagine that there are a lot of such strategies which are used in different situations. For example, depending on the time, depending on a lot of other cases. In such case, we would need to add new strategies, new handling inside logic of a single class, which will lead to completely unstable code at some moment. And there's also one little problem here, which is not obvious at the beginning. The problem is that we depend on the system resource here. So take a look at this. Let's try to see some test for this. That's the, let's see, bad order service test again. Bad order service test. In the bad order, The problem is that, for example, we would like to cover just one case. Again, there could be a lot of cases because there are a lot of branches. A lot of branches inside the code for each different strategy. So if we wanted to verify that Christmas discount is applied correctly, should apply Christmas discount, we would need to write something like this. We would need to place the order using the order object, something like that. Give some values, verify if they're OK, and then actually what about the total cost? About the total cost, the problem is, as you can see, where is the part where we create the date? Where is the current date here? If you run this test, just like that, the problem is that we cannot even write an insertion for this. We cannot even write verify here about the repository, mainly because we cannot know what's the current date, and we cannot depend on the system resource, which is a clock. So that's the first thing about this code. It's untestable because we refer to the system resource in this line, local date now. It's quite easy to refactor, yeah, that's right. But if we had a little bit more complicated code, which is hidden somewhere deep inside the dependencies, deep inside some other modules, it might be absolutely impossible to refactor it with such ease. So that's a problem here, right? We cannot give the right clock, so we don't know what's the context. We could probably use such things as power mock, but that's very, very bad. So in such case, I really think that most developers would just abandon writing this case, would not really unit test this because they don't know. They don't know how to refactor this if the dependency on the resource is hidden deep inside the code, right? It's much simpler actually in this case because I am showing micro scale problems, right? So they're manageable for the needs of this presentation. But in the real world, that would be a lot of problem. And there are also a lot of cases, right? We are not going to write all of them, like should apply greater than 350, 200 discount, and we also need to need to think about the prioritization because if there is a requirement, we need to apply only one discount. We need to also write tests about the prioritization of the discount. So, for example, first X must then 350 discount when greater than total cost, etc., etc. And for each new strategy, we would need to write a lot of new tests for the same module. Quite unmanageable. So how would it look in the good case? Refactor is not so hard because it's a micro problem, as I said, because it's a microcode here. By microcode, I mean it's very small, not anything related to microservices. Don't think about it this way. In the good layer, in the good case, applying the order discount would be much easier. Because actually, we would refactor the order to the class called good order. And there would be a calculate total cost method directly inside the model, inside the business model, which uses discount policy in line 22 here. So that's one way we could possibly refactor the code. We could refactor the model, switch the problem, move the problem to the business model where it belongs, actually, and then just apply discount policy. So if the logic of the calculate total cost looks something like this, policy discount for this order, then sum multiplied by the discount, to verify if any discount is applied correctly, we can create any stub discount policy. For instance, here created in the line 19th line, which is a very simple lambda, which just halves the total cost by just halves the total cost, right? it's 0.05 here. So that's quite easy, right? It's all we need to test in the model, directly in the good order model, to verify if we can apply any discount. So what's also great about this design is that we can quite easily create new policies, new strategies. For example, if we wanted to verify if Christmas policy works as expected, all we had to do is to write code just for the Christmas discount policy, not for the integration for entire classes, not integration for entire graph, for entire system, just this. Should return 08 discount when current date is 1st of December 2018. That's the one case, one example. And that's quite close to the specification, right? To the examples, as you said, to the business examples. That's quite easy, right? We just have a discount for the order. We are using the discount. We are using the Xmas discount, Christmas discount account, which can take a clock and calculate the local date based on the clock. And then have a very, very simple logic, just like this. And this allows us actually to inject also a fixed clock, because we can create mocked clock, just like this. Fixed UTC clock, for example, that's a utility method I created for the needs of the presentation. I'm using clock fixed and then some manipulation of local date, so I just can give year, month, and day. And this way, we can have a clock that will always return the same day. So for each case, we can simply create a new fixed clock. For example, should return one discount, so the value is 1 because it's out of the scope. So should return 1 discount when current date is 24th of December, because in the business requirements we might have that when it's after 24 there is no discount, or the discount could be different. It's just like this. So in such example, if we wanted to test the time, all we had to do just inject inside the Christmas discount policy different fixed clock and verify if it behaves correctly. And that's all. And the heavy part of the logic is actually shifted again to the policy, which is part of the business model. And we could do the same for each new policy. New policy, okay, new test for the policy. No need to write any other kind of test, just for this policy. We verified in the good order test, in the discount policy test, here, no, not here. I'll open it again. That's this part here, order discount test. We verified here that our order can apply a discount. Okay, great. So if you want to test the logic of any discount policy, we just create new discount policy and test it in isolation. So that would be much better. Okay. So maybe another case. Yeah, maybe I'll just first explain about the problem here before we move to the new test. The problem with this code was the thing called cyclomatic complexity. Cyclomatic complexity is a metric in software development, in software quality development, which basically means the number of cases we need to write, the number of test cases we need to write to have a full coverage. So the bad order service we had previously was a kind of this problem, that there was a lot of strategies implemented inline inside with a lot of if branches, if else, then apply this, right? So basically that's a number of if switches, else switches, such kind of things, which is also related to the number of cases we need to write to have a full coverage. So the another case I wanted to talk about is layered architecture. Probably a lot of you heard about layered architecture, probably a lot of you use it. That's quite famous, I would say. That there is an application layer, there is a controller layer, or view layer, depending on how we call it. There is a model layer, which is often called the business model layer. Yeah, and there is usually a data layer, sometimes called repository, sometimes grouped as packages, sometimes grouped as modules, sometimes grouped as separate services. Depends on the architecture, specifically of the architecture. So basically, that looks like this: that there is a package controller which takes controller package which takes all the input, delegates to the package application layer, just like this. This layer, application layer, talks with the model and talks with the repository. And basically, that's all about it. These lines here are because package repository need to persist the model. And the other line here is because we use JPA annotations. So that's not the full view of the architecture we actually have here. But the basic question is, where is the place in order logic, which is our main case in this scenario? We want to place an order. That's our main business scenario. Where is it placed? When comes a new developer and he or she asks, where is this logic? Where should I start working with this code to understand it? What would we say? That's naturally in the application layer, because in the classic architectural layer, logic is usually shifted to the application layer. So yeah, you can see here that there is a place order method, such things like this. Maybe again, I will show a live code here. I'll move to the layer, application, just like this. Nothing fancy. We can see there is a part of the logic we have previously seen inside the controller, just like this. So we say, yeah, that's great because we keep the controller clean, right? And then another problem is that there's also a thing called validation. There is also a thing called validation, which means that we need to write a part of the code also inside the order controller. And someone might argue that simple validation belongs to the controller. Yes, if that's a simple DTO validation. I agree. The problem here is that we are not actually having in this code a very simple validation. You see, actually the responsibility of the model leaks to the controller here. Order cannot be already placed, but we don't want to crash the processing, so let's set the right value. So we set the place to false, so we are not sure, because you see we are using order here, not any place order command, not any DTO, we are using order. So if we have order inside the method here, we need to think about what happens if some value is given inside the JSON as placed. So yeah, it should be false always, because we just want to place it after it's processed. So we need to set it to the false, right, value. Just like that. OK. And then the total cost must be empty. So we are not really sure what currency we use, but USD is always fine, right? So we want to have a 0, but we are working with the currencies here, both in the presentation layer and both in the business model. So we need to set the total cost of money 0 using the USD, because we always use USD. Why not? OK, and then the other problem is here that finally we call the order self is below, many lines later. So that's also a part of the logic we are having leaking here in the other layer. So what's the problem? There's also a date. Somewhere we set the current date when we persist the order. That's another case here. So we are persisting it somewhere here, order date updater. We are using the event listener for the pre-persist event generated by the repository. And then we set the current date always to the local date. And now that's, well, Again, a new problem here we are having. So finally, the question is, well, what about the model? What about the model, which should have logic here? The model is just plain simple, just stupid. There is no any logic here. It's just a bunch of properties. So imagine testing such code. We would need to, if we would like to verify a place and order business behavior, we would need to test all the layers. That's, well, that's such a big problem, I don't even want to try writing tests for this here. And there's another reason, finally. When forcing unit testing is a bad idea. When forcing unit testing can be a waste of time when there is no actual logic. There are parts of our software, usually called the glue code, which don't contain any kind of business logic inside. There is just some command to process. We are delegating this command to the service. We are saving this in the repository and then updating the statistics service here. So what's the problem? The problem is that generally there is no any logic here. If we wanted to use unit tests to write it, we would be forced to have a lot of fun using mocks. And when having a lot of fun using mocks, just like this example, you see we are having a configuration for place order service. When is place order on the given command, then we should return order. Then we should mock the repository and mock the behavior for save order on the repository to return another saved order, and then finally mock the integration with statistics service. So yeah, all these lines just to configure some behavior depending heavily on the implementation and depending heavily on the usage of the methods inside it. So if we, for instance, changed save to save something or save all and pass a collection, our tests will fall apart because they are extremely brittle. In such case, any change to the implementation would involve changing also tests, which is another reason not to write unit tests for developers. So instead, what should we do in such example? In such example, instead of having such situation, we should run simple integration testing, for instance, using some Docker repository or embedded DB, because we don't have any real logic here. There is no need to write any unit tests here. In example of classic user finder code, finders code, that's quite common here. You can see that in this example, when we have just one glue code method, here user finder is extremely simple. We simply return the result from the repository. If we enforced writing unit tests for this user finder test, it might seem like an easy job, right? We simply mock the repository, find by name, and return collection of expected users, and then verify if we called the right repository method. Simple. But there is a fallacy inside it. There is a problem with this code. Again, we are mocking the part of the implementation. We are working based on the assumption we always call find by name method. But we can actually have the same code produced, the same results produced when I can run this, so you can see it works. Yeah, that's natural, quite obvious, because there is no any logic here. I mean, we mock everything. But if we change the user finder code here to have an equivalent code, but calling different method, calling find all, then stream, then filter by name, which is not very optimal, right? But it works. It works. It should work. It's the same result produced here. Then user finder test will fail. So that's the problem, because we mocked just the find by name method of the repository class. So instead of using such kind of tests, we should simply write very simple integration testing. Save some users to the database. Run the user finder and verify if it integrates well with the DB. That's all. It doesn't depend on the implementation used. Because again, that's the case when we don't have any real logic. We just have a part of the integration code, a part of the glue code. We should not write tests, unit tests, for glue code. There is no any logic here. So that's another case against unit testing. Some developers might say, OK, that doesn't work. That's useless. Our tests fall apart, are extremely brittle anytime we change anything inside the implementation. So what's the gain? There is no gain. You're using unit testing in the wrong way. OK, so where are the limits? The limits lie in our design, but also in our heads. Because when we learn something, we try to use exactly the same tool for exactly the same for each problem. Each problem is a nail, you know this saying. And each solution looks like a hammer. But we should not use always the same tools. So instead of this, we should not blindly apply unit testing or any other methodology. It doesn't work. In case of this presentation, what I wanted to tell you in the second example, why unit testing don't work, is don't unit test the glue code. It makes no sense. There is no logic to test, so don't test this. Instead, unit test the real logic, because that's the thing we have any control over inside our code. Yeah, so this presentation was part of the Jukemeister competition. So if you liked it, I would really appreciate if you vote for me. If you didn't like it, don't do this, please. Yeah, no, that's joke. I really like to hear constructive feedback. So just go to the inventory application, find test limits, Michał Wojtyna, and please rate this. I would be really grateful for this. So yeah, thanks all for your time.